Okay, in this project, we will write a smart contract with Solidity to create ERC-721 tokens. That means non-fungible tokens. When we create those tokens, we will write a smart contract to convert metadata of non-fungible tokens to mint and put in the blockchain as token URI. And also, we need to write a smart contract for managing those tokens or those NFTs on the marketplace. So we need to write two smart contracts, especially on this section. And to create those tokens for this section of the course, I use ERC-721, which is one of the most popular standard for creating non-fungible tokens. So this is already a hard hat project. I already set up this hard hat project, and now I want to start writing a Solidity code in here. So what I will do is I come to this contract section and I want to create a new file. As you see, Hardate gives this log.sol file as a default file. So what I want to do, I will create a new file. So firstly, in this section, I wanted to create or write a smart contract which helps me to mint tokens. And in the next section, I want to write a smart contract for managing those tokens. That means those minted tokens in the marketplace. So especially in this section, we will write two smart contracts. The first is which helps us to mint the tokens, mint non-fungible tokens by using this ERC-721 token standard. And on the next part, we will write a smart contract to manage those tokens on the marketplace, like listing those tokens on the marketplace, selling, buying, and those tokens. So we will write those smart contracts in the next section. For now, I want to write a smart contract for minting. So what I will do is I will give NFT dot. So I will give this name. You can't give any another name. So I give this name. After that, what I will do, this is a Solidity file. So we need to write a pragma. That means we need to write a Solidity compiler version. So I write pragma and I give the compiler version, for example, 0.8.20 like this. For example, this compiler version is the most important thing you need to put in your smart contract, especially when you use this Solidity smart contract. You need to put these pragmas because we need to convert those smart contracts into bytecodes and APIs, application binary interface, because we need to deploy those smart contracts on the blockchain. So blockchain doesn't understand this Solidity code, so blockchain understands a binary code. So we need to convert this Solidity program to the binary and application binary interface. So we need to do those things. For that, we need to put this compiler version. So pragma Solidity, and you need to put this compiler version. And also this is a license. So the code license, I will put it MIT. That means this MIT means open source. So we will put like this. When you write a smart contract on Solidity, you need to put those things on the top of your file. That means this license and also the compiler version. After that, you will write your code. So after we put this compiler version and this license for our code, we need to write a smart contract for converting non-fungible tokens metadata to NFTs. That means we need to write a smart contract. The main functionality is for minting. For that, I write contract, and the contract name I give is NFT. So I will declare this contract and I give the name NFT. Okay, after I declare this contract NFT, then I will put this some important points. That means what are the main functionalities we will implement in here. The first is creating ERC-721 tokens. So when we create non-fungible tokens, the standard is ERC-721. We need to use this ERC-721 token standard. This is the most important part we will consider, because you can also mint or create non-fungible tokens by using another standard like ERC-1155. So in this case, in this project, I want to use this ERC-7021 as a token standard. The next important thing is we need to mint those tokens. That means we need to implement a minting functionality. So we need to mint function. We need to mint non-fungible tokens, not fungible tokens. So we need to mint none. We need to mint these non-fungible tokens. This is another important thing. So another consideration we will see inside this contract is that after we minting these tokens, we need to put the token URI. So we need to consider token URI. That means when we minting non-fungible tokens, as we know, non-fungible tokens have their name, price, and also image. So we need to put those things. That means this token URIs or metadata on a token URI, and also we need to consider one token has one unique ID. That means this is non-fungible. Non-fungible means one token is not exchangeable to another token. So one token or one NFT has one unique ID. So one NFT have, so we need to consider those things. We need to store their metadata URI inside this smart contract. We also we have mint functionality. We need to use ERC-721, and also we have one NFT with one ID. So one unique ID have one NFT. No two NFTs have unique the same ID. So we need to consider those things. So the first is when we need to use this ERC-721 token standard, we need to import. So to use this ERC-721 token standard, we need to import it. So for using this ERC-721 standard, I wanted to use OpenZappling from the OpenZappling library. So you need to write npm inside this terminal, npm instead, and you need to write OpenZappling contracts. By writing this and hit enter, you need to install this OpenZappling library. I already installed it, so when we come to this and package.json file, as you see, I already installed this, so I don't install it again. So you need to install this npm install OpenZappling contractors to use OpenZappling. For me, I already installed it, and what I will do is I want to import this ERC-721 token standard from the OpenZappling. However, I want to store this token URI, so we need to import ERC-721 URI storage instead of this ERC-721. When we come to this node modules and when we see this OpenZappling, inside this OpenZappling there is a contract here, and inside this contract there is a token, and inside this token there is ERC-721, and inside this ERC-721 there is extensions, and inside these extensions I want to use this ERC-721 URI storage because we need to store our URI. That means the NFT URIs in this contract. So what I wanted to do, I wanted to import this ERC-721 URI storage instead of importing this ERC. And when we see this ERC-721 URI storage, it also inherits this ERC-721. So what I wanted to do is I come to this NFT part. So I write import, and I want to import OpenZappling contracts. Inside these contractors, I wanted to come to this token part, and inside this token, I will come to this ERC721. By the way, this code editor also, I use this Visual Studio, so it also suggests me. So ERC721. Then after this ERC721, I want to come to this extension part. Extensions, and I come to this ERC721 URI storage. ERC721 URI, this URI storage. So I want to import this. You can also import ERC721, however, not that much important because this ERC721 URI storage also inherits ERC721. So you can use ERC721 functionalities by using this ERC721 URI storage. So I come to this contract part again, and I wanted to inherit this contract, this ERC721 URI storage contract, to my contract this NFTs. To do that, I write is, and I want to write this ERC721 storage, ERC721 storage, like this. By doing this, I want to use all the functionalities inside this ERC721 URI storage to my contract this NFT. This is, I think, very clear. So first, I want to use this. So this standard ERC721 standard, and we need to store token URI. To store token URI, I use this URI 721 URI storage from the OpenZapply library. And this OpenZapply library ERC721 URI storage also inherits ERC721 token. So by inheriting this ERC721 URI storage to my contract, I can use all the functionalities of this URI storage to my contract. Okay, this is the first step. So the next step is we need to pass some parameters inside this constructor. Inside this constructor, and also we need to instantiate ERC721 tokens, because this URI storage uses or inherits ERC721. So I write this ERC721, and this ERC721 token needs two things mainly to create those tokens. So the first is the name, and the second is the name of the token, and the second is the symbol of the token. That means when we come to this part, when we come to this ERC721, and when we see this ERC721, when you use this constructor functions of the ERC721, it needs two things, the name and the symbol, as you see. So we inherit this ERC721 token in our tokens. So we need to pass those things, the name of the token. The name of the token I will give, for example, AOG, like this. We need to pass those things as a string. And the second is the symbol. So the symbol is AWG, like this. So I pass these things for ERC721 like this. Okay. After that, after we put this, we will move to the next part, which is this minting functionality. We implement this ERC721 token standard in our contract. To do that, we inherit this ERC721 URI storage from the OpenZapply, and we inherit our contract with this URI storage to our NFT, and our NFT contract now have access this ERC721 URI storage. This is the first one. The next part is implementing this minting functionality. So to do that, I want to create a function inside this contract. So I write function. I wanted to use this function definition function, and I wanted to give the name mint token. I wanted to give this name. You can also give another name. That is not a big thing in here for the naming of the function. So I write this, I create this function mint token, and the main purpose of this function is to mint non-fungible tokens by using ERC-721 token standard. So to do that, after I write this, I want to give the functions visibility, so I will do it public, and I want to pass some things inside this mint token function. What I will do, I will pass string memory, and I want to pass token URI like this. We need to accept token URI to mint those tokens. Token URI means URI which have image and also description and title of those non-fungible tokens. So I will pass this. After that, after I accept this token URI inside this mint token, the next is we need to return a token ID, because when we mint one token, we need to return a token ID. So token ID is a number, and we need to return uint like this, or uint 256 like this. We need to return a number. So when we see this function, the mint function, I give the mint token as a function name, and this function accepts a token URI to mint non-fungible tokens. This token URI have the name of NFT, metadata, that means image, and also description of those non-fungible tokens to mint, and it returns a token ID. So I come to this part again to the top, and I want to create a variable called token ID, because we need to store or track every tokens which is created inside this NFT. So I want to write uint to 5 seconds public the visibility of the variable, and I give the name token ID like this. So this is the token ID. You need to consider this first, by the way. Every token has one ID. So one NFT is minted, it is one ID, which is labeled given one ID. So what I will do, I will come to this part, and when we mint one token, we need to increase those ID by one. So token ID, I come to this minting function, and I will increase token ID like this. When we call this mint token function, we increase token ID by one. That is why I do this token ID plus plus. After that, I will implement the internal minting functionality inside this mint token. So I will write mint like this, and I will pass some parameters inside this. So if you are not familiar with this internal mint function, this mint function comes from this ERC-721 token standard. So when we come to this ERC-721.sol token, which is imported from the OpenZapply library, when we come to this, there is a mint function here, I believe this. When you see this, this is a function which is used to convert the token metadata to NFT. So we need to use this mint function. So we already inherit or import this ERC-721 token standards. For that, we can use this mint function. So this mint function needs two things. The first one is to, that means the address, and also the token ID. It needs token ID. So I come to this, and I will pass two parameters inside this. The first is to, the address, that means to which address this NFT is labeled. So we will write msg dot sender. That means the color of this mint function. So this is the first one, and the next one is token ID. So the token ID is, I will pass token ID like this, because I created this variable in here, this token ID. So by passing this, the msg to sender as an address and this token ID, we can mint those tokens. Next part is I want to set this token URI, because this is a non-fungible token and we need to set those token URIs with those token IDs. For that, I want to use set token URI like this. I wanted to use this function set token URI function because I already imported this ERC721 URI storage. So when we come to this part and when we see this URI storage, there is a function called set token URI here. So we need to use this set token URI to put the token ID with this URI. For that, we need to use this set token URI, and when we see this token URI, set token URI, it accepts two things. The first one is the token ID, and the next parameter is the token URI. So I come to this part, my contract, and the first is the token ID. So I write token ID like this, and the next part is string memory token URI. So I will pass this variable token URI. So I write token URI like this. By doing this, it sets a token URI by using the token ID and the token URI like this. After that, after we do those things, the next part is we need to give a functionality for the marketplace. So we need to interact with the marketplace contract. This is a minting functionality. That means this smart contract only mints tokens and send to the MSG sender, and also it sets a token URI with token ID and the token URI we pass in this parameter. So the next part is we need to giving an approval for the marketplace to manage those tokens. So to do that, I want to come to this again. I want to create a variable address public, and I want to give them name marketplace contract like this. I create a variable marketplace contract, and inside this constructor I want to accept, before deploying this smart contract, this minting smart contract, we need to accept a marketplace. For that, address marketplace. I want to accept this marketplace contract before deploying this, and I will, inside this constructor function, I will put marketplace contract equals with this marketplace contract like this. It's a very simple concept. What I want to do is I want to give approval or give the power to interact those tokens, those minted tokens inside this smart contract, allowing the marketplace contract to operate on those things. So I will do this, and after that I come to here again and I write set approval for all. I will use this function set approval for all from ERC721. When we see this ERC721, there is a function called set approval for all. I think this is internal function. So This is a function I use. So set approval for all. It needs two things, the operator and the approve. That is a boolean true or false. So who is the operator? The operator of those contracts, those tokens, non-fungible tokens, is this marketplace array. So I write marketplace contract, and the next parameters is a bool, so true. I will write this. So by doing this, we can give the marketplace contract to interact with those tokens, those minted non-fungible tokens. So I will give those functionalities. After that, I want to return. When we call this mint function, we need to return a token ID. So I come to this and return. I want to return token ID because when we mint a new token, we need to assign a new token ID. So when we increasing our minting, we will create a new token again and again. So this token ID also increased, and we can know those minted tokens by this token ID, and we need to return this token ID. So by doing this, we can create non-fungible tokens by using ERC-721, and this is the main functionality for minting new tokens or non-fungible tokens. So I believe that this is very clear. To revise this very fastly, the first thing we will do is we need to write a pragma in here because we need to compile this Solidity smart contract into the bytecode and also API application binary interface. And also we need to import this license. After that, we import this ERC-721 URI storage, and this ERC-721 URI storage also inherits ERC-721. So by inheriting this ERC-721 URI storage to our NFT contract, we can use any functionalities inside this ERC-721 URI storage. And I create a token ID variable and a marketplace contract variable, and I will give the name ERC-721 with this name and this symbol. After that, we create a function mint token, and we will accept a token URI as a parameter. After that, we increase token ID. When we mint a new token, we need to increase a new token ID. And I use this mint function and set token URI. This mint function is the main purpose of this mint is to mint non-fungible tokens, and it accepts the address. This msg.sender means the color of this smart contract, and this is a token ID. By taking these two parameters, it mints a new token, and this set token URI uses to set token non-fungible token URIs with their token ID. So we will put this token ID and the token URI. After that, we give a power to operate this marketplace contract over those tokens, like to transfer those tokens and other things. So we approve this, set approval for all with this function, and we give a power to operate on those tokens with this marketplace contract, and we will return this token ID inside this mint function. So by doing this, this is a minting function NFTs, and it returns this token ID of those tokens. So this is the minting. In the next part, we will write a smart contract for the marketplace. We already imported this marketplace contract as a variable. This is an address of those marketplace. So in the next part, we will write a marketplace contract, and we will write a contract to manage those tokens on the marketplace. Okay, now let's get started to create a smart contract for the NFT marketplace. Previously, we write this NFT.sold smart contract, and the main purpose of this smart contract is for minting non-fungible tokens by using ERC-721 token standard. So by using ERC-721 token standard, we can mint non-fungible tokens, and the purpose of this contract is for minting non-fungible tokens. Now we create Solidity smart contracts for managing those non-fungible tokens for the marketplace. That means we write a smart contract for listing non-fungible tokens and also buying, selling functionalities. So we'll write a smart contract for the marketplace. For that, I create a new file. Inside this contract, I create a new file called marketplace contract dot sol. I give this name. So after this, the first thing is I wanted to write a pragma for the compiler version of this smart contract. So I write pragma and I will put the compiler version. For this, I wanted to put a compiler version which is 0.8.0 greater than or equal to. I will put like this and less than 0.9.0. This is another form of writing a compiler version in the Solidity. So previously we will use a caret sign like this. We will write this caret sign and we'll put like this. This is the same as the previous one. This compiler version, this caret sign means the compiler version with starting from this up to 0.9, not including 0.9. Or we can write also like this, greater than or equal to like this and less than 0.9, 0.9.0. Two of them are the same, so we need to put this compiler version, and also we need to put this license identifier. For this license identifier, I will put MIT like this. This is a compiler version, and it is the most important thing to put on your smart contract because we need to compile this smart contract for deployment, and we need to get the compiler version for interacting with those smart contracts. So we need to put this like this. And next, I wanted to use OpenZapply library. So in the previous section of this course, I will already show you how can you install and import OpenZapply library. You can install like this: npm install openzapply contracts. By doing this and hit enter, you can install OpenZapply library and you will get that module inside this node module. I already installed it, so I don't install it again. If you are not installing this OpenZapply, you need to install it because I wanted to use ERC721 token standard from the OpenZapply and also another contracts from the OpenZapply library. So after I import it, I want to create a contract, declare a contract like this. I want to declare this and I will give the name marketplace like this. This is a contract name I give. So contract and marketplace like this, and inside this there is a constructor function. We will do those things. For now, I want to import some contractors from the OpenZapply library, like the interface of ERC721. In the previous contract, if you remember, we import this ERC721 URI storage like that. I also import the ERC721 token standard interface. So this is a marketplace and I wanted to interact with the tokens, non-fungible tokens, which are created by ERC721 token standard. For that, we need to import the interface, this interface ERC721, because this ERC721 is a token standard and this is a marketplace. This contract is a marketplace contract, so this marketplace contract must be interacted with these tokens, ERC721 standard tokens. For that, I want to import this interface. So import, I write import, then open the plane contracts token Then inside this token, I wanted to use ERC721, and I wanted to import interface. This I means interface of ERC721 dot. So this is the contract I need to import. So you can get this contract inside this bulk module. After that, you come to this open Zeppelin, and inside this open Zeppelin there is a contracts. After that, you come to this token, and inside this ERC721 there is this IERC721 token. So by importing this IRC721 token interface inside this marketplace, we can get access to interact with these IRC721 tokens inside our marketplace. And also for this marketplace, we need to implement selling functionality, buying functionality, and also we need to transfer tokens from the owner to the marketplace and the marketplace to the buyer of that NFT. For that, we need to protect our smart contract from some vulnerabilities like reentrancy. So to protect that, I wanted to use reentrancy guard inside this contract. For that, I wanted to import reentrancy guard from the OpenZap library. For that, I wanted to import it. Import at OpenZaplin. 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 Then inside this OpenZaplin, there is a contracts here. I come to this contracts, and inside this contracts, there is here is a contracts. There is security in here. Inside security, there is a reentrancy guard. So what I will do, come to security, and inside this security there is a reentrancy card. So I wanted to import this. Import OpenZaplin contractor security and reentrancy card.sol file. So I wanted to import it, and also I come to this contract. My contract marketplace is I want to inherit this reentrancy. So is reentrancy like this. So contract, which is a marketplace contract, this is a contract name I give, is this reentrancy card. That means I want to inherit this reentrancy card into my marketplace contract. That means this reentrancy card functionalities are implemented inside this my marketplace contract. So by doing this, we can implement this reentrancy card functionality in our marketplace contract. This is the first step. The next step, inside this contract, I want to create some variables inside this marketplace contract. The first variable is I wanted to track the tokens which are listed in my marketplace or inside this marketplace. So for that, I wanted to create a number variable uint, or you can write uint 256. That is the same. So uint 256 public or private. I want to make it private variable. So I want to create a private variable called token IDs. Like this, I want to create variable called token IDs. The main purpose of this variable is to track or to count the number of tokens or non-fungible tokens which are listed in the marketplace. So this is the first variable we need to implement inside this contract. Another important thing we implement is we need to track the number of tokens or non-fungible tokens which are sold out. That means after those tokens are listed in the marketplace, we need to count the number of tokens which are sold out. For that, I wanted to also another variable uint 256, and also I make it private variable, the visibility private, and I wanted to give the name tokens sold. Like this, I wanted to create a variable like this. So this token sold variable tracks the number of tokens which are sold out after they are listed in the marketplace, and someone comes to the marketplace and buys those tokens. This token sold variable tracks those number of tokens which are sold out. like this. After that, I want to create another variable, which is the owner. So I want to track the owner of this marketplace. For that, address, owner is an address. So address public, I make it public, and owner, like this. I give the variable name owner. Then I wanted to also create another variable which determines the listing price. That means I wanted to put some amount of tokens to list those tokens, or if the user comes to this marketplace and wants to list their NFT in this marketplace, they need to pay some amount of money. For that, I want to create a variable called listing price. So I will create a variable uint 256, and I make it visibility public, and also I give the name listing price. Listing price, and I want to put some amount of ether, for example 0.045 ether, like for example ether, like this. So this is another variable, listing price. So if a user comes to this marketplace and wants to list their NFT in this marketplace, the user needs to pay this amount of ether to list in the marketplace. This is a listing price. So I did this, and after that I come to this constructor function, and inside this constructor function, it is a function and it is called at once. So this constructor function is called when this smart contract, this marketplace smart contract is deployed. And what I want to do is I want to set up this owner variable. So owner equals payable, and I want to make the owner msg.sender. So this, inside this constructor function, I pass this owner equals this msg.sender. This msg.sender means the color of this function. That means the color of this constructor function, and the color becomes the owner of this marketplace contract, because this constructor function is called at once, and when this smart contract is deployed. And by doing this, I want to make the owner this msg.sender. That means the deployer of this smart contract. So after this, the next part is creating another function. I want to create a function which returns the listing price. For example, when a user wants to list their NFT inside this marketplace, we need to return this function. So I create a function, and the function name gives I write get listing fee or price, like this. I give this name function get listing price, and inside this I want to the visibility of this function may be public. I will put it public, and I will put it view, and it returns the price. So uint 256. That means it returns a number because it returns the price, this price. After that, I write return. I want to return listing price, like this. It is a very simple function which helps to return the listing price. So by doing this, we can create a function called listing price, and this listing price returns a listing price of variable like this. So I will create this function, and this view means there is no other writing or modification of this smart contract. This is only view. That means only returning something, not writing inside those smart contracts. That is why I will put this view, and this public is the visibility, and the visibility of this smart contract, this function is public, like this. So by doing this, we can create this get listing price function. Okay, after we create this get listing price function, the next part is creating a function which allows the user to list their NFTs inside this marketplace. That is the next step. So Now we create a function for allowing NFTs. So the next step is creating a function which allows the user to list their NFTs inside this marketplace. For that, we need to implement some important things. The first one is we need to track the information of one NFT. For that, we need to create a struct. I want to create this struct and I give the struct name or market item or token. I will give this as a struct name struct market token. I give this or NFT token. You can't give any struct name. For me, I want to give this a market token. And next, I want to put some variables inside this struct to implement or to track the informations inside one NFT. For that, we need to put the first thing is we need to get the item ID of one NFT. For that, you int 5 seconds, and I want to give or create a variable name item ID. So I create this variable. This is the first variable, and this item ID means the ID of one NFT. That is, so we implement this. The next is address, then NFT contract. The contract address of that NFT. This is another variable we need to have inside this or each NFT. So the next one is we need also track the token ID. You int 256 token ID like this. This is an item ID and this is a token ID. So the difference is this item ID is an ID which is listed inside an ID which is given by this marketplace for one NFT when this market token or the NFT is listed inside the marketplace. However, this token ID is an ID which is given by the smart contract, or when we mint those NFTs, we return this token ID. So this token ID and this token ID is the same. However, this item ID is given by this marketplace for each NFTs which is listed inside this marketplace. So you need to understand the difference between this item ID and the token ID. The next is we need to also put the seller of this NFT. For that, address, payable, and seller. That means for the first time this seller becomes the lister of this NFT. So we need to this seller address. The next is also we need to track the owner of each NFT. For that, address, payable, and owner. So this owner and this seller is different. For example, when a user comes to this marketplace and lists their NFT inside this marketplace, he becomes a seller and the owner becomes, for the first time, the owner becomes this seller of that NFT. After he lists those NFTs inside the marketplace, the owner becomes non-owner, or this marketplace becomes the owner. And after that, when another user comes to the marketplace and buys this NFTs, the owner becomes the buyer. So this seller address and this owner address is different due to those situations. So we need to track those owner and also the seller. Another important thing we need to have those NFTs inside this marketplace is the price. So we need to also track the price. The price is a number. So I write you into 5 seconds and the variable price like this. This price means the price of one NFT or each NFT. That is the price. And another important thing we need to know inside each tokens inside this marketplace is if they are sold or not sold. So we need to track those things. So I use bool and sold like this. Sold a variable. And if the NFT is sold out, this bool becomes true, and If the NFT is not sold, this bool becomes false. So I create this token, market token, or you can give another name like NFT token or whatever you want to give. So for now, this struct have, or this market token struct have those informations and tracks each information for each NFTs which are listed inside this marketplace. The next important thing is I want to create a mapping and track those market tokens or this struct with unique ID. For that, I write mapping, and I want to change this arrays to uint to 5 seconds. That means I want to give a unique ID for each tokens or each market tokens, and I want to put this market token like this. I create a mapping with each unique ID with a market token struct, and I give the name, make it private first. I wanted to make it private and give this ID to market token. I give this name. So I want to track each of these tokens with a unique ID like this. This mapping helps for that. In other words, this ID to market token have a list of tokens which are listed inside this marketplace, and it maps with ID, unique ID, and those informations, this market token informations. So I do this. And in the next part, I wanted to create a function, and I wanted to allow the users to list those tokens inside this marketplace smart contract. So I wanted to create function. And I give the name make market. I give this name function make market item. You can give any name, by the way. For more simplicity, I give this make market item, and the purpose of this function inside this contract is to allow the users to list those tokens inside this marketplace. So the first one is this function to be public. I will put this public and also payable. I wanted to make this function payable because to list each NFTs inside this marketplace, the user must pay this listing price. For that, this makes payable. And when we put this payable, we need to put none reentrant, which is a function I imported here, reentrant card. So I must put this none reentrant, and I want to remove this returns like this. So this is a function which helps the user to list their tokens inside this marketplace smart contract. So this is the first step. The next thing is to list those tokens. We need those informations like item ID, NFT contract, token ID, seller, owner, price, and sold. So for each NFT which is listed inside this marketplace, we need to pass those informations. For that, the first thing is inside this make market item, I want to pass some parameters. Those are, the first is address and the address of this NFT contract. Address, NFT contract, NFT contract. This is the first one. The next important thing we need to pass inside this function as a parameter is token ID. We also need to pass the token ID. So uint to 5.6 token ID. This token ID. Then we also accept as a parameter the price of this token or non-fungible token. So price is uint to 5.6 price. We need to accept those as a parameter inside this function. Then we need to check some important things and allow the user to list those tokens inside this marketplace, and also we need to add those tokens inside this ID to market token. So the first thing I wanted to use require. So require, I wanted to use this require, and we need to check the price is greater than 0. That is the first thing, because we don't allow the NFTs which are 0 price. So we need to check price. That means the price variable imported here, price greater than 0. This is the first thing. If not, we need to say the price must be greater than 0. The price I will pass this. Require price greater than 0. This is the first thing. Sorry for this. I want to change this R to this required. So the next important thing we need to check is the user address or the lister address, how at least to pay the listing price. For that, I wanted to write require and msg dot value greater than or equal to price, listing price. This listing price is a variable we created here. So in case of this, we need to accept this. So we need to check the color of this smart contract, which is msg, and his wallet address must have at least this listing price. So if not, we need to say you must pay listing price like this. This is the next important requirement to check inside this function. That means we require the price of each NFTs which are listed inside this marketplace must be greater than 0. That is the price. And also we need to check the user have a value to pay the listing price to this marketplace. After that, we need to move the next part. The next part is if one token is listed inside this marketplace, we need to track by using this token ID. For that, we need to increase this token ID. So what I will do, token ID is a variable I created, must be increased like this. This is an important thing. So each token is listed inside this marketplace, this token ID is increasing. So we can track and give a unique ID for each NFTs which are listed inside this marketplace. The next important is I want to create a variable uint to 5 seconds and the variable name item ID. I will give a variable ID like this, and I want to put this token ID like this. What I will do is I want to create this item ID and I want to pass the value this token ID. Okay. We move to the next part, which is we need to put this NFT which is listed inside this marketplace must be put those information inside this ID to market token, and we need to refer with an ID. So for that, I want to write ID to market token like this with a unique ID. The ID is item ID. This item ID equals with, we need to put the information of this struct. So market token becomes market token, and we need to pass those informations for this struct. The first thing we need to pass is this item ID. So this item ID becomes item ID like this. The next important thing is NFT contract. So I will also put NFT contract here. NFT contract, which is a contract address, comes from this parameter. Then the next part is the next parameter information is a token ID. So I also accept token ID, this token ID. Then from this market token struct, the next is seller. Seller becomes msg to sender and it is payable. So payable and msg to sender. msg dot sender. This is the seller. The next is the owner of the smart contract. So when that NFT, one NFT is listed inside this marketplace, the owner becomes no address. So what I will say, payable and address with zero address like this. There is no owner like this. Okay, the next information is price. So price becomes price. That means we need to accept inside these parameters this price. And lastly, we put this true or false. That means if this token is sold or not. When this NFT is listed, it becomes false. That means it is not sold. So false. I will put it false like this. This is important thing to track this NFT information. So we create a new item with this item ID. That means it have information like item ID, NFT contract, token ID, seller, address, owner, and price, and it is not sold. By doing this, we push this NFT information into this mapping ID to market token. This is the first thing. Then we need to implement some important things. That means we need to transfer those NFTs into the marketplace address. From the seller address to the marketplace address. For that, we need to use NFT contract address. This is the NFT contract address, and this NFT contract address must be interacted with this interface IRC721. This interface is we imported here. So from the open subline, this NFT contract address is interacted with IRC721 token. After that, we call a function from this contract. We call a function transfer from this transfer from function, and this transfer from function accepts three parameters. The first one is address from. That means from which address these tokens are transferred. For now, we need to the seller address. So msg dot sender. This is the first one. The next is it needs two address. That means from the seller to the marketplace. So we need to pass address with this address. This means this smart contract address. So this smart contract address is this marketplace address, and the third one is the third parameter is the token ID. So we need to pass token ID. That means which is the unique identifier of those NFTs. So by doing this NFT contract and calling this transfer from function from this ERC721 token standard, we need to pass or transfer the NFT from a message sender, that means the seller, to this address, this smart contract address this, and token ID. We need to pass the token for identifying each NFT. This is all about to list those NFTs inside this marketplace. However, we need to emit some information. As for that, first I create event to emit this information. So I come to this part, this top part, and or I come to this event. I will create event, and this event I give the name, the event name, market token listed I give this name market token listed, and I will emit some information. The first one is uint to 5 seconds, index it, and the first one is item ID. We need to emit item ID. This is the first one. The next one is NFT contract. This NFT contract. So address, index it, NFT contract, NFT contract. The next important thing we need to return is uint to 5 seconds, index it, and token ID. This token ID, and also the next is address, seller. Next is address, sorry, not address. After this seller, the next is price. We need to put this uint to 5 seconds price. And lastly, we need to return bool sold. I create this event. These are the events, so I create those events, and now I come to this part inside this function and I want to emit them. So emit, we need to emit those informations. The first one is item ID. The next information, this item ID is this ID. So the next is, sorry for this, emit, and we need to pass this event name. So this, I will copy this market token listed. So that is why this shows error like this. So emit the market token listed, and the first one is item ID. That means this, we need to pass this like this item ID. The next is this NFT contract. Sorry here. This NFT contract. So the next one is NFT contract. This NFT contract becomes this, and nextly we need to pass a token ID. Token ID here. Then we need to pass a message to sender. That is the seller. When we see this event, this after the token ID there is a seller. So address seller. So the seller is msg.sender. That means the color of this function. And the next part is we need to pass here after the seller there is owner. So I ignore here address owner. So this address owner becomes address 0. So address with 0 like this. Then the next information here inside this event is after the owner there is a price. So the price becomes the price of this NFT. This price, I will pass price here. Then lastly, if this token is sold or not, so I will pass false like this. So this is the important thing. You need to emit those informations. So I create the event here for market token listed, and I will also emit here. So to revise this in shortly, this is a function to allow the users to mint their NFTs inside this marketplace. So we create a struct called market token, and this market token have information for each NFTs like item ID, NFT contract, token ID, seller, owner, price, and so it is sold or not. So those information, those NFT information for each NFTs, those informations are tracked by this market token struct, and I create this mapping to store those information, the token NFT token informations with a unique ID. So this ID to market token stores informations for each NFT tokens. After that, we create a function called market item, and this market item accepts NFT contract, token ID, and price to list those NFTs inside this marketplace, and it checks if the price is greater than zero, and also it requires the value must be greater than this listing price, because the lister of this NFT inside this marketplace must pay the listing price. So we require those things. After that, we increase these token IDs. So we create these token IDs inside this contract to track the list of NFTs which are listed inside this marketplace, and we give a unique token ID for those NFTs. For that, we need to increase these token IDs inside this make market item function, and we create item ID variable and stores those token IDs inside this item ID. So by using this ID to market token with this ID, unique ID, we need to pass those informations like item ID, NFT contract, token ID, owner, and also this seller and owner, and also the price, and if it is sold or not. After that, we call this function transfer from function from this NFT contract, and we transfer the NFTs from the owner or the seller to this marketplace contract, and this address this means this contract address, and we need to also pass this token ID because this transfer from is an ERC 721 contract. So when you come to this contracts and inside this token there is ERC-721, and when we see ERC-721 there is a function called transfer from. So this is a function I use, transfer from, and it needs address from address to and token ID. That means it is non-fungible token and it is identified by this token ID. So by doing this, we need to transfer those NFTs into this marketplace address, and after that, we need to emit this market token listed by giving this market token listed. I create this event and emit some. So this is a very important step to list NFTs inside this marketplace. Okay, after we create this make market item function, which is most important for listing NFTs inside this marketplace, the next important thing we implement inside this marketplace is allow the users to buy those NFTs. So for that, I wanted to create another function here, another function which allows to buy the NFT. So this is the next important thing. We need to write a function or implement a function for the users which allows the user to buy NFTs which are from the listed inside this marketplace. So I create a function called, I want to create a function and I give the function name create market sale. I give us this as a name. So I create a function called create market sale which allows or executes the selling of those NFTs inside this marketplace. For that, we need to accept two things. That means the user calls this function, the user needs to pass two things. The first one is NFT contract, and this is an address. This NFT contract is address. So address NFT contract, and the user also need to pass the ID. That means the unique ID to buy those NFTs. So each NFT have a unique ID. So the user must be pass an ID to buy. So you int 256 ID like this. I will make it like this ID. So the user or the caller of this create market sale function needs to pass two things: NFT contract and also the ID. That means a token, NFT token have an ID, so they must pass those unique ID. And I will put it visibility public and make it payable, and also non-reentrant. I want to make it non-reentrant, and I'll remove this return. Then inside this function, we need to check two things. The first one is we need to calculate the price. That means get the price of that NFT within this ID. So each NFT information is stored inside this ID to market token. So we need to get a price. For that, what I will do, you int 256. I create a variable called price to get the price of that NFT and ID to market token, and I pass this ID inside this variable ID to market token like this dot, and I wanted to get the price like this. So this is the first thing, because we need to get the price, because the buyer of this NFT must pay this price. The next is also we need to get the token ID. So you int 256 token ID equals with ID to market this variable with this ID dot this token ID like this. So this is the first thing we need to check. We need to get the price and also the token ID. After that, we need to require the user to pay the price of this NFT. For that, we will create a require and msg.value greater than or equal to price. Price means this NFT, one NFT price. So if not, the user must be the buyer, sorry. This is the first one. So the buyer must pay the listing price. No, not the listing, the price of the each NFT. So we get the price of the each NFT inside this ID to market token. This is ID to market token is a mapping variable we create, and it stores all NFTs which are listed inside the marketplace, and we extract one NFT which is depending on this ID, and we get the price, and this price must be, this msg.value must be greater than or equal to this price. So this is a first requirement. After that, we need to execute those things. The first thing we need to do is we need to transfer this price value to the seller, because we have a seller address in here. So we need to transfer the value from this buyer to the seller. So what we will do, ID to market token with ID like this. This variable dot seller, we need to get the seller information. After that, dot transfer. We call this transfer function, and this transfer function is a value. So msg.value. By doing this, we need to transfer this like this ID, sorry for that. This we need to get the seller address, and we need to transfer this msg.value. That means this price amount of the price of this NFT to the seller. This is the first important thing, because the price of this NFT must be sent to the seller of that NFT. The next important thing is we need to transfer those NFT from this marketplace to the buyer. So the next is I will use IERC, this interface, that means ERC 721 interface, and I this code this NFT contract is an interface of this ERC 721, and we'll call transfer from function, and we need to transfer a token from this address. This address means this smart contract address to the user or the buyer, and we'll also pass a token ID. For that, we write address this address. This means this contract address, because when list those NFTs inside this market by using this market item inside this marketplace, we transfer those tokens from the seller to this seller to this address. This address means the smart contract address. Now, from this marketplace address to, we need to change this, transfer this address to the buyer. The buyer must be msg.sender, and we also pass token ID like this. This is the next thing we implement. That means we transfer this NFT from this marketplace address to the buyer, and this token ID is the NFT ID. Then we change or modify some informations about that NFT. The first one is the owner, so we need to change the owner. For that, ID to market token with this ID dot owner, because we need to change the owner. So the owner becomes this message dot sender. That means the buyer of this NFT. So msg dot sender. The owner changes from this address 0 to this buyer. So the NFT buyer becomes the owner of that NFT. The next important thing is we need to update also this sold or not. So we need to make it sold true. So ID to market token with this ID dot sold becomes true, like this. And also we need to update the information. Those information is we need to track these sold tokens by using this tokens sold variable. So I want to increase this tokens sold variable plus plus. It tracks the sold tokens like this. And lastly, I want to payable with owner dot we need to transfer listing price like this. This code transfers the listing price from the seller to this owner. So this is a very simple function which allows the user to buy NFTs inside this marketplace. To revise this, I create this create market sale function, and this create market sale function accepts two parameters: the NFT contract address and also the ID of that NFT. And it is an interact. After that, it fetches the price from this ID to market token by using this ID. This ID is this ID. So it fetches two things: price and token ID. After that, it checks if the buyer can pay the price of that NFT or not by doing this require. After that, it transfers the value or the price from the buyer to the seller. It transfers this message dot value. After that, it transfers the token from this marketplace contract to the buyer of this NFTs. This message to sender means the color of the function owned when the color of the function becomes the buyer, and it transfers from this marketplace to the buyer. After that, it updates those informations from this. When we see this part, this track market, each market token have those things, the seller, owner, and also this pool. So we need to update this the owner becomes the buyer. That means this message to sender and this sold becomes true. After that, it increases this token sold because it tracks this variable token sold. Variable tracks the tokens which are sold from this marketplace. So it increased by 1, and also it transfers the listing price from the seller to this owner. By doing this, we can create this create market sale function. It allows the user to buy NFTs from the marketplace.